Hello friends, we will again start the same tutorial which we left last time, and this time I want to tell you in details what we have taken, how and where they are from, and so that you will have refresh if you look at the if you have seen my previous video. So this is the same file which we created last time. This is MM1. I left it here, and I'll go in details about everything starting from the met file. So for met file, the format is .met, and that you have to generate through some software which will come back to you later on, and you will use that one software to generate. But first you have to enter everything in the Excel sheet, and from the Excel sheet, this is the year, then day in Julian days, then solar radiation, maximum and minimum temperature, and rainfall. You can see the units of this. So solar radiation megajoule per meter square, and sometimes in long-term data you may not have solar radiation. In that case, what you have to do is to convert from and get the solar radiation from maximum and minimum temperature, and once you get that one, then probably your weather file will be completed. And I also already, once you get your solar radiation, all those things, then probably it will be easy to draw a chart that I have already mentioned last time, and you can call back, and you can take the default one, and that is already there in the file, in the AppSim folder. You'll get those things. Then you move to clock. In the clock, then I already mentioned clock symbolizes the duration of simulations, whether it is 1 year or 10 months, or it is 10 years, or it is 100 years. And it's very easy to editable. Usually you give 1 or 2 months before the showing of the crop to initialize the model, and we initialize the soil profile data, then we initialize other parameters in the soil profile. So it is easy to edit these things. I have told you last time when you watch my video, you can see from the previous one, and it is the duration of simulation, and you can change according to your own will depending upon the duration of the climate file. So next, summary file that I mentioned you. This summary file comes when you completed the simulation run, and everything your input data, whatever input and output, that everything, and the simulation run, everything will be there. I think we will come back to this later on. Let me move to the paddock where you have all the you know soil data, where you have initialized the soil water content that I already told you how we did. And this is most important, the profile data. If you don't have this data with you, then probably you can take one standard from soil, and you can you know you can see there are in this toolbox, you'll have so many things: standard, graph, soil management, and all those things are spam. So in soil, you can see there are from soil from Bangladesh, there are from Indonesia, South Africa, USA, and Australia. Though we have a lot of data for AppSim format, but it has not been included here. But you can use your own data by bringing one such file. Suppose if it is a black soil, then probably you have to bring one black soil from here and drop it there, and it will take automatically. Just like click it here on your left cursor, then drag and drop it here, and you will find in the paddock there will be arrow. Then you drop it here, and you can see that it is there, and you see all those details will be here, similar things. And you can change your own value, and simply click on it and put the delete, and it will be deleted. So you can have that soil file from this toolbox. Similarly, if you want to work on suppose similar soil types, suppose from Bangladesh one, so probably Indo-Gangetic plain will may represent to some extent, but you can see those things. You can also drag one of them, different types of silt, silty clay, loam, all silt. So you can have all those things. They are in AppSim format. You can drag and drop it here and change accordingly yours. But if it is in the black soil, probably this will fit, and You can change your own data here, your bulk density value, your lower limit means permeability percent. You can change. You can delete it. It is very much editable. You can delete any. Suppose you want to make it 122, 125, then probably you can do it. Otherwise, uh, you know 120 to 150 it was there, so you can keep it again. And depending upon your soil profile data and availability and depth of soil, probably you can edit any one of them, put your own values, and you can run the simulations. So this is what soil water constant, and you can see all those values of EU, summer EU, winter EU, then Kona, then soil albedo, all those things, slope of the land, you can change according to the literature or the availability of data sources. And uh, so you can have your own database, you can change it here. And soil organic matter, as I mentioned here, then similarly, you can have your organic. So it depends upon the same depth, whatever you maintain here. Suppose your profile is 150 centimeter or 1.5 meter depth, and interval is like that, then it should be in the organic carbon also similar depth is maintained, because you have to take care when you bring those soil profile data from this toolbox and drop it here. You have to see that whatever they are in water content here and depth as well as interval depth intervals, the similar things will be there. Otherwise, there will be error in the simulation when you run it. Then analysis, don't think about all these things at this time, because if you are working on such salinity or all the other salt concentration in the soils, probably that time you may require it, otherwise not. Then initial nitrogen content, I already mentioned that how we get it. Then similarly, three depths, here, here, and here. The depth, depth of soils and intervals should be similar, and your values, I told you it is in ppm. If you have kg per hectare, you can make it kg per, simply clicking, right clicking it, then you get, then again right click, then come to ppm, then right click, then come to ppm. So it is up to you the value you have. And this value is 2 molar KCl extractable. It is not some other country different types, but it is 2 molar KCl extractable ammonium nitrate content, so you have to put those values here. Then this is soil organic matter module, and we show that this is the wheat crop staples will be there, and approximately 100 kg, 1000 kg or 1 tons will be there initial surface residue, because there will be stubbles definitely. And CNS is 80. If you have CNS less than that, probably you can use. And fractions of residue standing, if you put it 0, you can put it 0.2, 3, 4, 5, and if you work on conservation agriculture, probably you can change it here. Then fertilizer module, because this is required here, by default it is coming, unless otherwise the nitrogen content in your management folder will not work. So nitrogen application, it is governed by this fertilizer module. Then surface organic matter is carbon as well as the residue standing on the surface. Or you are, if you are applying any other farm-made manures, compost, or any other wastes. Then coming to wheat, that module, the crop module. Then in that case, I already mentioned you to first, if it is there, because you have taken the wheat default simulation, so this module will be there attached to it in the simulation tree. But unless otherwise you have any file which will bring it from here, from the standards. So unless otherwise you bring the ini file from the structural, that's ini file, and drop it here, as I mentioned last time also, you can bring and drop it here by clicking on the left side of your cursor and drop it here, then probably you'll get ini file. There are two, so I am deleting again straight away. And from once you open this ini file, probably you have to browse, and I told you last time how you get these things. Similarly, browse it and go to where you have those ini file, where you have actually your model. Then probably you bring from the XML file and find out the suitable varieties from where you're going to use for your simulation. And those varieties are, by default, there are many varieties of different durations you'll find for spring wheat as well as winter wheat, and you choose your one. And if you have a new variety which you want to run the simulation or you want to work on it, then probably at that time you need to generate the coefficients and go for parameterization and calibration of the model, and you probably go for validation. That is a different part that we will talk about later on. But at this stage, you can run the model. You can use the default one. Already I used one. So that the variety we have calibrated and validated for our own purpose. I am just showing that one. And in the management folder, where all your cultural practices will be there, starting from sowing to harvesting. In the sowing, what do you do? In the sowing, actually sow the crop. In the sowing time, what we follow, similarly the crop we are sowing is wheat, and this process is known as sowing. And how much fertilizer you are adding at this time: 120 kilogram of nitrogen in the form of urea. Then sowing on a fixed date. In that case, where we have sown on 15th of November. Usually I took a default one, but it depends on you how you do it. But it's editable. You can have, but you have to follow the same format what is mentioned here. 15 dash NOV. The N can be capital or small, doesn't matter in this case now. So the crop you are sowing is wheat, and the plant population 120 depends on how many plants are there for a meter square per meter square, that you have to enter here. Then sowing depth, so 5 centimeter or 50 millimeter. The variety, see, drop down so many varieties are there, but I have used mine which we have calibrated or validated for our own conditions. To enter the growth class, it's a crop, definitely it's a plant. And row spacing depends on you. If you make it 300, if it 30 centimeter, you can 30 or 300 millimeter or 30 centimeter distance row to row. But in our case, I put 2 to 5. So in the meantime, when you keep on doing this, keep on saving this so that whatever changes you made in your file, that will be saved. Then harvesting rules. In harvesting, so sowing there, harvesting there, in between intercultural operations, as you know, model assumes so there is no weeds, control over weeds. So we assume that the pest, diseases, and weeds are controlled here, and they don't interfere in plant growth. So in that case, that's why you don't have many intercultural operations. We'll go for water as well as nutrient. And in nutrient, we are going for nitrogen. And in that case, already I told you fertilizer at sowing, we have applied 100 directly just to show you. But you can go for split application in two splits. Suppose one you want to apply at the time of sowing, suppose it is 60 kilogram, half of this, and rest at crown root initiation, which is between 20 to 25 days. In that case, what you have to do from the management toolbox, you have to go for management common task, and you can see there are so many things are there. So fertilize, uh, or there may be fertilize on fixed date, suppose, and top up. You can bring it and drop it here, and you see. So when you are fertilizing, suppose similar format, you can write, suppose if it is 15th of November, so add another 25 days, 15 plus 50, 30th of November, and also December 15. So you write 25 in December 10. So you write 10 dash month means DEC. So in that case, you can go for this top of this, and amount of nitrogen you can write it is here, suppose 60 kilogram. Already you know that, and the form of where model would come from, it is the fertilizer model. So you can add accordingly. So that means you are going for second installment, and first installment 60 kilogram. You can change it here, and second installment of here 60. So that means you are going for split application. But for simulation run, I just should show you that you are going for this one, just to show you how you can go for top of fertilizer. You can do. So I am deleting this one just to show you that it can be done. So similarly, irrigation debt. So on irrigation, it is irrigation on event. So on event means that wheat crop it requires pre-sowing irrigation. So we are going somewhere irrigating at the time of sowing, and that I mentioned last presentation, last tutorial. So here we are going to give around 60 millimeter of water, irrigation water, and irrigation efficiency. So you are applying all those irrigation that will be available to the crop. So to whom model come from? It is a wheat and soy. Then irrigation on debt. So we know that there will be around 4 to 5 irrigations required for wheat crops. So you have given one pre-sowing and four post-sowing. You can go for five also, depending upon the duration of the crops. It is short one or extra early variety if you have, then probably number of irrigation will be reduced. And so is your application of nutrient or nitrogen. So here I have given one pre-sowing irrigation that I have mentioned here, irrigation on nutrient, that's a sowing, and irrigation on date, that means post sowing 1, 2, 3, 4. You can see the format is similar to that of date, but I have given one space in between. If you don't give one space, probably that will not work. So that will give problem. So you have to see that this will not create any problem. So where it will come from, it is come from irrigation module. So I put irrigation one. That means when you run it, then probably you have given optimum nitrogen, you have given optimum irrigation, you have sown the crop, and you are harvesting the crop. So the management folder is complete. Then in that case, what next is, as I mentioned, your output file. Once you run the simulation here, you can see, run the simulation, you'll find, because we have given the variables, these variables are there in the output files are reported frequency at harvesting. You are getting only one data, biomass, yield, and all those things, whatever parameters are there, only one value, because it is giving to go wheat harvesting. So you go for 10 years, 10 values will be there. And based on your frequency report and variables, you get those outputs. And what you'll find that these outputs we can plot also. And for plotting, I told you we can have, date here. In the biomass yield, you can put more grain protein, but grain protein, you just click it on left click on your cursor, the grain size, then probably biomass nitrogen. But I'm not sure how many things, because if there will be very small values, suppose you can add like that. Since the values are less, it is giving, it's coming late, but you can do by clicking it here again. So the values are coming different because they are very less, so they are at the bottom. But now when I click this one, they are going bottom, but if I unclick it, then they are here. You can reduce them. So simply you can have to these values, you can have any values up to, you can click it here. And here while plotting also, you can add more, no, not there. You can delete it here also. You have to know this. So which one is marked, it will go there only. So suppose estimated water content also is going. So again, I'm going for plotting. I got one more here, you see. So like that, whatever you want to do, you'll get those values. And see, with estimated water content, how the profile water content is varying and all those things, grain, biomass. So I mean to say that you can plot those things, you can have those values, and more important thing, the output, it can be, you know, you can take it to Excel. Simply clicking on the Excel, it is coming. See, it will be saved somewhere. It depends upon where actually it may be saved. You have to check where it is saved. Output file dot out. So you can click it, and you'll find that it is saving in Excel. And from here, you can make your own graph depending on which type of graph you are going to make. You can take from here. Otherwise, you can use that graph also, but you can make your graph according to the need of the journal where you want to publish it. So this is what, then coming to the summary file actually, because I am repeating the same thing what we did last time. This summary file, you can see that in the profile, everything in details you will find in the summary. When start of the day, end of showing, we have started 15th of November. You can show the plants. You remember we are given plant density 120, showing depth 50 millimeter or 5 centimeter cultivar. We use Sujata, row spacing to 25 or 22.5 centimeter. And you'll find everything detailed, soil property, depth wise, water holding capacity, initial soil, albedo values, then a slope, all those things, whatever is there, we have taken, and you'll find those input values here, and initial soil organic matter content, and the model has estimated from based on the soil carbon content, humus, nitrogen, biomass, carbon, biomass, nitrogen, fresh organic matter, nitrogen, fresh organic matter. Then start of flowering, how many days it took, is the thermal time taken by the, in the whole process. You'll find year wise, you'll find, and first year also, 15th of 1980, you have sown the crop and you have added the fertilizer, and see with time how the different growth stages, and you'll find the stover biomass, nitrogen content, and biomass production. And you can find the summary here also. Whole summaries when the flowering comes, then maturity day, how many days it took to mature, then grain weight, you can see the stover weight, then grain yield tons kg per hectare, you can convert it to tons per hectare. The grain yield weight, that may be 10 to 15% weight. Moisture content in the grain depend. That's why the value is more than the moistureless content. And unlike that, only harvest index also you'll find CN ratio, all those things, nitrogen content, all those things you'll find. Then average stress indices, you can find that it is showing, so there are some stress at the time of grain filling, means nitrogen stress, nitrogen grain. So you can stay when the plant was under stress. So like that, actually, you'll find everything, whatever you have, top of the residue, root, and nitrogen content, total dry matter, everything, every year, continuously for 10 years, you'll find it. So friends, what I think, I have just summarized everything what we had in the last presentation. Hope you like it and learn something, because I am repeating again. I know first time it is difficult to understand most of the things. So what I did actually, I again wanted to show you again, so that when you do by yourself, you won't face any problem. If you face any problem, do write to me. You have my email ID. You can post your comments here, so that I will take care of your needs. Thank you very much. Thank you once again for listening to me. Have a great time.